Hello students, today we are going to study mix design. The procedure of selecting suitable ingredients and determine their relative proportions with the objective of producing concrete of having certain minimum workability, strength and durability as economically as possible is known as mix design. Now the various factors to be considered in specifying a concrete mix are water cement ratio, cement content gradation, consistency of the fresh concrete. Now requirements of concrete mix design. The requirements which form the basis of selection and proportioning of mixed ingredients are: the first one is the minimum compressive strength required from structural consideration. Next one is the adequate workability necessary for full compaction with the compacting equipment available. Next one is maximum water cement ratio or maximum cement content to give adequate durability for the particular site conditions. Next one is maximum cement content to avoid shrinkage, cracking due to temperature cycle in mass concrete. Now the types of mixes. The first one is nominal mix, another one is standard mix, and the last one is design mix. Now what do you mean by nominal mix? In the past, the specification for concrete prescribed the proportions of cement, fine and coarse aggregates. These mixes of fixed cement aggregate ratio which ensures adequate strength are termed as nominal mixes. These offer simplicity and under normal circumstances have a margin of strength above that specified. However, due to the variability of mixed ingredients, the nominal concrete for a given workability varies widely in strength. Now next is the standard mixes. The nominal mixes of fixed cement aggregate ratio by volume vary widely in strength and may result in under or over rich mixes. For this reason, the minimum compressive strength has been included in many specifications. These mixes are termed as standard mixes. IS 456-2000 has designated the concrete mixes into a number of grades such as M10, M15, M20, M25, M30, M35 and M40. Here M represent the mix and 10 represent the characteristic compressive strength, which is shown here, that is the 28 days cube strength of mix in Newton per mm square. Now the mixes of grades M10, M15, M20 and M25 corresponds approximately to the mix proportion of 1 raised to 3 raised to 6, 1 raised to 2 raised to 4, 1 raised to 1.5 raised to 3 and 1 raised to 1 raised to 2 respectively. Now the design mixes. In these mixes, the performance of the concrete is specified by the designer, but the mix proportions are determined by the producer of concrete, except that the minimum cement content can be laid down. This is the most rational approach to the selection of mix proportions with specific materials in mind possessing more or less unique characteristics. Now the approach results in the production of concrete with the appropriate properties most economically. However, the design mix does not serve as a guide since this does not guarantee the correct mix proportion for the prescribed performance. Now the factors affecting the choice of mix proportion. The first one is compressive strength. It is one of the most important properties of concrete and influences many other describable properties of the hardened concrete. The mean compressive strength required at a specific age, usually 28 days, determines the nominal water cement ratio of the mix. Next is the workability. The degree of workability required depends on three factors. These are the size of the section to be concreted, the amount of reinforcement and the method of compaction to be used. Next one is the durability. The durability of concrete is its resistance to the aggressive environmental conditions. High strength concrete is generally more durable than low strength concrete. Now the next is the maximum nominal size of aggregate. In general, larger the maximum size of aggregate, smaller is the cement requirement for a particular water cement ratio, because the workability of concrete increases with increase in maximum size of the aggregate. Next is the grading and type of aggregate. The grading of aggregate influences the mix proportions for a specified workability and water cement ratio. Coarser the grading, leaner will be the mix which can be used. Very lean mix is not desirable since it does not contain enough finer material to make the concrete cohesive. Now the next one is quality control. The degree of control can be estimated statistically by the variations in test results. The variation in strength results from the variation in the properties of the mixed ingredients and lack of control of accuracy in batching, mixing, placing, curing and testing. The lower the difference between the mean and minimum strength of the mix, lower will be the cement content required. An example illustrating the mix proportioning for a concrete of M40 grade as per IS 10262-2009. Now, stipulations for proportioning. The grade designation is M40. Type of cement is OPC 43 grade conforming to IS 8112. Maximum nominal size of aggregate, that is 20 mm. Minimum cement content, that is 320 kg per meter cube. Maximum water cement ratio, that is 0.45. Workability, that is 100 mm by slump test. Exposure condition, that is severe. Method of concrete placing by pumping. Degree of supervision, good. Type of aggregate, crushed angular aggregates. Maximum cement content 450 kg per meter cube and chemical admixture type super plasticizer. Now test data for materials. Cement used is OPC 43 grade. Specific gravity of cement, that is 3.15. Chemical admixture, that is super plasticizer. Now specific gravity of coarse aggregate, that is 2.74 and for fine aggregate 2.74. Water absorption for coarse aggregate is 0.5% and for fine aggregate, that is 1%. Free surface moisture. For coarse aggregate nil and for fine aggregate nil. Now this is the result of the sieve test which is shown here. Now the next parameter is the target strength for mixed proportioning, that is represented by F-CK, which will be equals to FCK plus 1.65 S, where F-CK is the target average compressive strength at 28 days, FCK is the characteristic compressive strength at 28 days and S is the standard deviation. Now from table 1, standard deviation, that is S equals to 5 Newton per mm square for M40 grade, which is shown here. Therefore, target strength will be equals to 40, that is characteristic compressive strength at 28 days plus 1.65 into S. So the target strength will be equals to 48.25 Newton per mm square. Now the selection of water cement ratio. From table 5 of IS 456, which is shown here, maximum water cement ratio will be equals to 0.45. Now based on experience, adopt water cement ratio as 0.40 because it is less than 0.45, hence OK. Now next is the selection of water content. From table 2, maximum water content for 20 mm aggregate will be equals to 186 liter for 25 to 50 mm slump range. Now estimated water content for 100 mm slump will be equals to 186 plus 6 by 100 into 186, that will be equals to 197 liters. Now as super plasticizer is used, the water content can be reduced up to 20% and above. Based on trials with super plasticizer, water content reduction of 29% has been achieved. Hence, the arrived water content will be equals to 197 into 0.71, it will be equals to 140 liter, that is the new water content. Now next is the calculation of cement content. Water cement ratio will be equals to 0.40, therefore cement content will be equals to 140 divided by 0.40, it will be equals to 350 kg per meter cube. Now from table 5 of IS 456, minimum cement content for severe exposure condition equals to 320 kg per meter cube, which is less than 350 kg per meter cube, hence OK. Now next is the proportion of volume of coarse aggregate and fine aggregate content. Now from table 3, which is shown here, volume of coarse aggregate corresponding to 20 mm size aggregate and fine aggregate for water cement ratio of 0.50, it will be equals to 0.60. Now in the present case, water cement ratio is 0.40, therefore volume of coarse aggregate is required to be increased to decrease the fine aggregate content. As the water cement ratio is lower by 0.10%, the proportion of volume of coarse aggregate is increased by 0.02%. Therefore, corrected proportion of volume of coarse aggregate for the water cement ratio of 0.40 will be equals to 0.62. Now one note is written here, that is, in case the coarse aggregate is not angular one, then also volume of coarse aggregate may be required to be increased suitably based on experience. Now for pumpable concrete, these values should be reduced by 10%. Therefore, volume of coarse aggregate will be equals to 0.62 into 0.9, that will be equals to 0.56. Similarly, volume of fine aggregate will be equals to 1 minus 0.56, it will be equals to 0.44. Now next is the mix calculation. The mix calculation per unit volume of concrete shall be as follows. Volume of concrete will be equals to 1 meter cube. Volume of cement will be equals to mass of cement divided by specific gravity of cement into 1 by 1000. By putting the mass of cement as 350 and specific gravity as 3.15, volume of cement will comes out as 0.111 meter cube. Similarly, volume of water can be determined by the same formula, that is mass of water upon specific gravity of water into 1 by 1000. By putting the mass of water value as 140 divided by 1 into 1 by 1000, it will be equals to 0.140 meter cube. Now next is the volume of chemical admixture, that is super plasticizer, at the rate of 2% by mass of cementitious material. So it will be equals to mass of chemical admixture upon specific gravity of admixture into 1 by 1000. On putting the value, we will get the answer as 0.006 meter cube. Similarly, volume of all in aggregates will be equals to A minus B plus C plus D. So it will be equals to 0.743 meter cube. Similarly, mass of coarse aggregate will be equals to E into volume of coarse aggregate into specific gravity of coarse aggregate into 1000. Now the value of E will be equals to 0.743 meter cube, that is the volume of all in aggregate. So on putting the value and solving it, we will get 1140 kg. That will be the mass of coarse aggregate. Now mass of fine aggregate will be calculated by the same formula. On putting the value, we will get the answer as 896 kg. Now mixed proportion for trial number 1. Cement will be equals to 350 kg per meter cube. Water will be equals to 140 kg per meter cube. Fine aggregate will be equals to 896 kg per meter cube. Coarse aggregate will be equals to 1140 kg per meter cube. Chemical admixture will be equals to 7 kg per meter cube, and water cement ratio will be equals to 0.4. Now one note is written here, that is aggregate should be used in saturated surface dry condition. If otherwise, when computing the requirements of mixing water, allowance shall be made for the free surface moisture contributed by the fine and coarse aggregate. On the other hand, if the aggregates are dry, the amount of mixing water should be increased by an amount equals to the moisture likely to be absorbed by the aggregates. Necessary adjustments are also required to be made in mass of aggregates. The surface water and percent water absorption of aggregates shall be determined according to IS 2386. Now next is the slump shall be measured and the water content and dosage of admixture shall be adjusted for achieving the required slump based on trial if required. The mixed proportion shall be reworked for the actual water content and checked for durability requirements. Now two more trials having variations of plus minus 10% of water cement ratio shall be carried out, and a graph between three water cement ratios and their corresponding strength shall be plotted to work out the mixed proportion for the given target strength for field trials. However, durability requirement shall be met. That is all about the mixed design. Thank you very much, students.